So in this manner, a decoder could be built using smaller decoders. So let's see another use. This is a very interesting use of a decoder. A decoder could be used to implement any Boolean function as a sum of minterms. Okay. Because each output of the decoder corresponds to one particular minterm, these could be just ordered together to create any Boolean function. So let's take a full adder as an example. If you recall, this is the truth table for a full adder, where these 3 bits are added together to produce a 2-bit result, which corresponds to the sum. The lowest bit is the sum and the higher bit is the carry, right? So for example, this combination corresponds to 1 plus 1, which is 2, so that's 1, 0. So this is the truth table for a full adder. Okay, and if you look at each of the output expressions and you write them out as a sum of minterms, then the output sum consists of the minterms 1, 2, 4 and 7, where it is 1 for these minterms, and the output carry consists of minterms 3, 5, 6 and 7. Okay, so now because our decoder already provides us all of these minterms, we can just order them together. So sum is produced by passing the minterms or the outputs 1, 2, 4 and 7 of the decoder to an OR gate. Similarly, output carry can be produced by passing these minterms 3, 5, 6 and 7 through an OR gate. So this is a very useful method of implementing combinational circuits that have many outputs. Okay, so this is efficient because whatever are the gates here in the decoder used for producing each minterm can be reused in forming multiple outputs. Okay, so this is a very useful way of implementing a combinational circuit where the outputs can be expressed as a sum of minterms. Another use of a decoder is for creating multiplexers or demultiplexers. So let's see how. If you recall, a multiplexer is a combinational circuit that has some select lines. Let's say it has 2 select lines and 4 inputs. So it's a 4 cross 1 multiplexer, and depending on the value of these select lines, the corresponding input is redirected to the output. So if select is 0, 0, then the output, the input A is redirected to the output, so Y is A. If the value of select lines is 0, 0, 0, 1, then B is redirected to the output and so on. Okay, so this is a multiplexer. In particular, this is a M cross 1 multiplexer where M is the number of inputs. How can we implement a multiplexer using a decoder? Well, we can use this for decoding the select lines. Recall that based on the particular combination of these select lines, we have to select or enable one of these inputs and propagate it to the output. So this can be done as follows. We just take a decoder, let's say a 2 cross 4 decoder, the outputs being D0, D1, D2 and D3, and these act as enable inputs to propagate each of these original inputs to the output. So for example, we AND D0 with A, and we AND D1 with B, and D2 with C and so on, and finally pass all of them through an OR gate to create the output. So depending on the value of the select lines, only one of the outputs of the decoder is asserted and all the others are 0. So accordingly, all of the other AND gates are disabled and only one of the AND gates is enabled, and that value, that input value, is propagated to the output. So in this manner, a decoder along with some AND gates and an OR gate can be used for creating a multiplexer. So what about a demultiplexer? A demultiplexer is the opposite of a multiplexer. Okay, it has one input line and multiple output lines. Let's say it has M outputs, and depending on the value of the select lines, this whatever appears on the input is propagated to the corresponding output line, right? So if, let's say, if select is 0 0, then the input is propagated to this particular output T0, let's call it M0, M1, M2, M3 and so on, and all the other outputs remain 0. Okay, so how can we implement this using a decoder? Let's say the input, let's call the input A. So it's very simple to implement this using a decoder. This is exactly a decoder. We can just take a decoder. Let's say if select, this is 2-bit select line and there are 4 outputs. So let's take a 2 cross 2 to 4 line decoder. Okay, and to the enable input, let's connect A. That's it. So what will happen is, depending on the value of the input combination, you connect the select lines to the input of the decoder. Depending on the value of the select lines, the value of the enable signal will be propagated to the corresponding output. So if enable is 0, all of the outputs will be 0. If enable is 1, then a 1 will be propagated to the corresponding output. So it's essentially the same as enable, this signal enable itself being propagated to the chosen output. So this n cross m line decoder can be, along with the enable input, can be used as it is for creating a demultiplexer.